The Astronomers celebrates the spirit of discovery and is made possible by the W.M. Keck Foundation, advancing the frontiers of education, science, and medical research. The W.M. Keck Foundation, investing in excellence.
In our lifetime, we have begun the journey to fantastic worlds. Worlds that for centuries could only be imagined. An aging explorer approaches its final encounter, while the world looks on. The first close-up images from Neptune. After many triumphs and discoveries, what will be the next frontier? For planetary astronomers, the next goal is finding planets around stars other than our sun.
What we'd really like to do is find out if there's other planetary systems out there with planets like Jupiter or even like the Earth circling around another parent star.
Astronomers now think they've found evidence of planets around other stars. Their search is driven by the oldest of questions. Are we alone in the universe?
We're beginning to believe that there was nothing really extraordinary in the events that led to the evolution of human beings. We are now at a threshold. It's just a matter of the willingness to go out into space and to examine the nearby stars and see if there are worlds there.
From a control room in California to the Andes Mountains in Chile, prospecting for planets. Next on The Astronomers. There's a road that cuts across a desolate stretch of central Chile. For some travelers, it leads to vistas beyond this Earth. It is the road taken by American astronomers Brad Smith of the University of Arizona and Rich Terrell of Caltech's Jet Propulsion Laboratory.
Instruments we've ever seen. We get to characterize them.
They come in search of other worlds, planets around distant stars. For 12 years, they have shared a friendship, deepened by frequent trips to this remote and barren land.
Yeah. Buy some cheese.
Goat cheese. You want to ask him how much?
¿Cuánto es? 500. It's 1,000.
1,000?
No, that's 5. What is it?
Hi.
500.
Why don't we give him 1,000 anyway? It's okay. Gracias.
For Smith and Terrell, the tiring days of travel are more than balanced by the chance to observe the southern skies.
An observing run overall is an exciting experience. You know what you want to do. You come down here and hope that the weather will cooperate. You're excited about the science you're going to get.
There's a tremendous amount of satisfaction in discovering something new. You come out here for a purpose. You've asked a scientific question. And that scientific question usually relates to a bigger puzzle, the meaning of things, where we relate to the universe, how we came to be.
Among the billions of stars in the universe, is ours the only one to harbor planets? This is the driving question for Smith and Terrell. In the foothills of the Andes Mountains, they follow a road to the Carnegie Institution's Las Campanas Observatory. Smith and Terrell bring specially designed equipment to attach to the telescope. Their device will reduce the star's glare to help search for planets that may orbit around it.
Eyepiece, periscope that allows us to look up through the eyepiece, one of the lens systems. spare shutter in case we have a problem with that. Miscellaneous boxes of tools.
Ever since I was a little kid, I was curious about science. I just lived and breathed and read all I could about science. First time, my parents told me this, first time I got hold of a screwdriver, I disassembled every doorknob in my house. I wanted to find out the way things work.
I guess my interest in astronomy began when I was about 9 years old. My grandmother gave me a book about the stars. I would go out at night with a piece of cardboard and a pencil and begin drawing them. I soon found that was a pretty big job.
Okay, we're ready for another exposure.
Okay. Yeah, I've got it pretty well aligned now. The periscope is out. The dark slide is open. This is the wide filter, 13 arc-second mask, and you go ahead and expose now.
Exposing.
Smith and Terrell's search for extrasolar planets grows naturally from years of pioneering work exploring our own solar system. During the last 30 years, automated space probes have given us dramatic close-ups of the Sun's family of planets. They have permanently changed humanity's view of its own cosmic neighborhood. The crowning triumph of these explorations has been the Voyager mission to the outer planets, directed from NASA's Jet Propulsion Laboratory in Pasadena, California. In Building 264 on the 3rd floor, the imaging science team led by Brad Smith receives signals from Voyager, telling of planetary worlds billions of miles away.
I think I just better. I've been with Voyager since 1972, and about a third of our team has been with us right from the very beginning. That's 17 years now, and it'll be about 18 years before we finish our analysis. That's a long time to work on a project.
Rich Terrell became an astronomer a year after Voyager began the epic journey that exceeded all expectations.
Spacecraft was launched in '77, which makes it about 12 years old right now. And I don't know if spacecraft age like dogs do or whatever, but the spacecraft has encountered its problems. It's deaf in one ear, essentially, one of the receivers. It's tone deaf in the other ear. It's got an arthritic scan platform. It's hung up on us several times. It's got memory lapses. It's got other, the kinds of things you can associate with degradation, with age. But nevertheless, it's got a personality, and it's also got a brain.
Voyager has traveled 5 billion miles, giving us an armchair tour of worlds never before seen. The one-ton spacecraft has radioed back tens of thousands of pictures and a wealth of data, information that will keep scientists around the world busy for decades. At JPL, preparations begin for Voyager's final planetary encounter. Ed Stone, chief project scientist, coordinates 200 researchers involved in this detailed survey of the outer planets.
Voyager really has, I think, surveyed the outer solar system and really shown us what literally dozens of new worlds look like. And one of the interesting things I think that we've discovered is they're very similar worlds in very fundamental ways, but they're also significantly different. Each one has an identity because of its particular origin, or more importantly, perhaps, because of a different evolution that it's undergone since its formation. The inner planets are small, rocky worlds which form near the sun where only rocky material was solid. Jupiter, Saturn, Uranus, and Neptune are giant gaseous planets formed in the outer solar system where there's lots of water, which is frozen, and therefore a lot of solid material to make giant planets, which then could accumulate vast amounts of hydrogen and helium to become the large planets they are.
Encounter after encounter, as Voyager reached each new planet, the mission scientists have reassembled at JPL. Brad Smith's imaging team has had to provide on-the-spot interpretations of pictures from each new alien world.
Yeah. The Mars polar cap, and
Yeah.
this is what it looks up close.
Yeah, okay, all right.
A little teaser.
First of all, Voyager has been just a series of surprises. And that in itself isn't surprising because this outer part of our solar system is what we knew least about from the Earth. Each planet, as it was further and further away, was less and less known to those of us who tried to observe these things from the ground.
But I think the first encounter with Jupiter really shocked a lot of people. It shocked the press because I think it was more colorful, more visual than anybody expected. And it shocked scientists because it was more unusual.
The atmosphere is variegated, almost psychedelic in its color. The surprise was the dynamics, the activity of this atmosphere, the way in which features interacted with other features in ways that we just never would have guessed.
Aya was perhaps the biggest shock, and maybe the biggest shock of the entire mission. Here's a moon around Jupiter, relatively small. We didn't really expect very much from it. Here's a planet, a world, where the geology changes on the timescale of human lives. While you're looking at the geology, it changes. If you lived there, you wouldn't get a weather report. There's no atmosphere, but you'd get a geology report. You know, mountain building to the east and floodplains to the west. The place is very, very dynamic. Here's a world that almost goes beyond the imaginations of science fiction authors, and it's a real place. It's in our backyard, orbiting Jupiter. The same thing was true at Saturn. There, the big showstopper was the rings. No one expected the kind of detail that we saw in the rings, and also the dynamics.
The rings, we thought we knew it all. We thought we understood them. We actually didn't expend that many images on the rings. So instead of seeing a few features that we had expected, the rings broke down into literally thousands of tiny ringlets. I guess at Uranus, the real zinger was Miranda. The smallest of the known Uranian satellites. We were looking at it closely only because we had to go close to it to get on out to Neptune. What a bizarre object that had all different kinds of geologies, like samples from everything we had looked at up until that point, all put together into this little object no more than 500 kilometers in diameter. Here we are now going on to Neptune, and we've learned that we're going to be surprised because we're coming into a system that we just simply don't understand, and almost anything that we learn about it, everything that we learn about it, is a surprise.
2 weeks before the close encounter with Neptune, the JPL engineers intensify their preparations for Voyager's flyby of the planet and its satellite worlds. Not only the planets, but also their moons reveal important information about the solar system.
In a sense, when we look at Jupiter and its satellites, or Saturn and its group of satellites, and the same for Uranus and Neptune, in some respects they behave as miniature solar systems in the way in which we think they form. They formed as a miniature example of a solar system, a large central body with others forming in orbit.
That could be just a
The data that Voyager has collected may ultimately help us in understanding other solar systems.
Voyager's data is providing clues to how planets may have formed. The Neptune encounter could help to confirm the picture astronomers have of how our planetary system came into being. 4.5 billion years ago, the solar system was born from a giant cloud of gas and dust. Denser parts of the cloud attracted the surrounding material. Gravity held the cloud in orbit around the center. Clumps of matter within the disk began to form larger and larger particles. The inner core grew so hot that nuclear reactions began, and the sun, our star, was born. As the sun grew hotter, a solar wind swept the lighter material outwards. In the hot inner region, rocky materials formed into the Earth, Mars, Venus, and Mercury. In the cold outer region, ice and gas combined to form the cores of the giant outer planets. Beyond the planets, a cloud of cold material remained in orbit around the sun. Although too dark and too distant for us to see, astronomers are certain it must be there. In California's Owens Valley, radio telescopes search for signs of other worlds, disks of material around distant stars. Caltech's Anila Sargent and Cornell University's Steve Beckwith have discovered disks of gas around young stars. They suspect that at least one star, H.L. Tauri, 500 light-years away, may be about to create a new solar system.
The one object we've really studied in depth is H.L. Tauri, and we chose this object because, in fact, over the past 10 years, there were other indications that the material surrounding this very young star was distributed not in a spherical envelope, but probably in some kind of elongated structure.
In the radio image of H.L. Tauri, Sargent and Beckwith have found an extended region they think is a disk, seen at an angle. Measurements of the motion in the disk show that gas moves in orbit around the star. Such a disk could be an early stage in the evolution of planets. H.L. Tauri is just one of many promising candidates for planetary formation that Sargent and Beckwith have found.
We don't just maintain this project at this observatory, we're doing it at several other telescopes. And so we had a rather large-scale project to look at about 86, 90 of these T Tauri, these early solar-like stars, on a telescope in Spain called, the facility's called IRAM.
What we actually found was that out of the 86 stars we looked at IRAM, 40% of them had disks of gas and dust around them, which are very similar to the conditions thought to exist in the solar system immediately prior to the formation of our own planets.
Astronomers have long known that about half of all stars have stellar companions, most orbiting in pairs, called binary systems. Why do some stars have stellar companions while others do not? Sargent and Beckwith speculate that many stars may have formed planets instead.
One good possibility is that when stars form, their residual matter, which goes into a disk, or when it's falling down in, either makes another stellar companion, or else it makes a lot of small bodies, like planets, such as we see in our own solar system. If that's true, we might be able to guess that approximately half the stars in the sky have binary system or stellar companions, and the other half have planets. And if the other half have planets, it means that planets are very common in the galaxy and in the universe as a whole.
But I'd just like to check if you think that the side captain probably will correct this, because we just feel better about the whole thing.
Astronomers are encouraged by the evidence that planets may be forming around young stars. But can they find planets already in existence? They would emit no light and no radio waves. Other methods of searching must be found. For Harvard astronomer and former off-road auto racer David Latham, the search for planets begins in his native eastern Massachusetts. 20 miles from Latham's home in Concord is the Harvard-Smithsonian Oak Ridge Observatory, where Latham has been surveying stars for planetary companions. Using an aging 60-inch telescope with an automated detector system, Latham believes he may have found a star with planets.
So how'd it go last night, Robert? Have any trouble with that high humidity?
We had a good run.
So that mean about 500 velocities this month?
Something like that.
Okay, I brought out the tape. I want to get the data transferred over. What we really want to know is how often stars, when they're forming, decide that they're going to have a companion star, which happens a lot of the time, or instead they decide that they'd like to have a family of planets. So in the last 6 years or so, we've done more than 25,000 observations. And it's this steady flow of data that allows us to monitor stars to see if they have any unseen companions, judging from the very slight motions that we can detect with this instrument.
Latham searches for planets by looking for the gravitational tug that a planet exerts as it orbits the star. The star wobbles only slightly in response to the weak pull from the much smaller planet.
So when we look for the motion of a star in response to the pull of its companion, we're looking for very small motions. Which of the stars out there have these tiny motions in response to the pull of their planetary companions? Without any planning, we backed into a very convincing discovery of a low-mass companion to a star. We, quite by accident, noticed that one of them seemed discrepant. It was deviating from the values that we'd been measuring by about 500 meters per second. So I want to see how bad this alignment problem is.
Latham's observations revealed a small wobble in the star, a back-and-forth motion from the gravitational pull of an unseen object in orbit around it.
And we went back and looked at all the observations, about 60 of them that we had accumulated, and lo and behold, we found an orbital solution that looked pretty good, but we sure didn't want to trust it.
Latham put the star, HD 114762, under constant surveillance. Astronomers at the telescope were instructed to observe it every night. Each night's data was immediately transferred by Latham from Oak Ridge to the Harvard-Smithsonian Center for Astrophysics in nearby Cambridge.
Hi, Bob.
All right.
Good present here from Oak Ridge.
Well, we'll see what we can do with it.
Within 3 months, the number of observations of HD 114762 tripled. Data from the telescope was fed into the Harvard computer, processed, and analyzed. The numbers supported the earlier observations. Something was making the star wobble.
So, have we found another planetary system around another star around HD 114762? Well, maybe. This object that we found could be as small as just about 10 times the mass of Jupiter, but remember, Jupiter's the biggest planet in our own solar system, and we're far, far away from seeing anything as small as the Earth. It's certainly not ruled out. The way to find out is to keep observing. Yeah, I'd like to take a look at the data.
As David Latham searches for planets around distant stars, other astronomers strain to hear faint radio signals from the Voyager spacecraft at the edge of our solar system. On August 17, 1989, JPL prepares for its final planetary rendezvous with Neptune.
Right now, we're 7 days away from closest approach, and if you can deal with that, you could talk about being 9 million miles away from Neptune, but, what does that really mean? If Neptune were the size of a basketball, okay, right now you'd be about 180 feet from the basketball. You'd be walking toward it at about 30 feet per day. So just during the last couple of days, you're going from seeing an object fairly remotely to getting incredibly close to it. We'll be getting pictures of Neptune essentially at arm's length. And the spacecraft itself will fly only about, on this scale, about 1.25 inches off the surface of it.
Neptune is, at the moment, the most distant planet from the sun, and it's dark out there. Something like 900 times fainter than the sunlight that we have here on the Earth. And that creates problems. It's like a photographer trying to take pictures when the available light is very low. The photographer can use a fill-in flash. We can't.
Well, it goes around the equator, all the way around.
Typical day would be in early, looking at the photo products. Did they come out? Did they come out right?
Candy Hansen has the unusual role of interplanetary camera director. Her job is to allocate Voyager's imaging time among the competing needs of several teams of scientists.
And this image of the great dark spot came down in the middle of the night. Pass that one around.
Right on. Yeah.
7 days before closest approach, pressures mount as overnight images must be analyzed before the daily 10 a.m. press conference.
Oh, am I first, or is that first?
Well, it didn't seem to matter. We had you first yesterday, and it didn't.
I couldn't make it.
For project scientist Ed Stone and imaging team leader Brad Smith, this is a week of discovery, decisions, and deadlines. As Voyager nears its target, the Neptune mission becomes the focus of worldwide attention.
La influencia terrestre que tiene la influencia espacial.
An army of 1,100 television, radio, and newspaper correspondents converge on JPL. Brad Smith and Ed Stone are tour guides on this journey to a brand new world.
Good morning. My colleagues in the imaging team are a bit tired, as might be expected, but they're also very excited, rather boisterous, because the images just keep getting better and better. Let's just look at some of the atmospheric images that have been received over the past day or so. Have the first slide, please. It's a view of some of our favorite features on the atmosphere of Neptune.
New images reveal Neptune as a dynamic and stormy world. The planet is streaked by 1,400-mile-an-hour winds, the fastest in the solar system. A giant storm as large as the Earth is a major discovery. It is named the Great Dark Spot.
As we come into closest approach. It's an incredible acceleration of knowledge that you get all at once. At the same time, you have half the scientific community looking over your shoulder, and the press is looking over your shoulder, and everybody wants to know what it all really means.
Well, let's put it announced for. Does that mean that there are others that...
You're not allowed to ask us questions.
Yeah, you're not allowed to ask us things like that, but I think it's safe to say...
Find the ones you can't ask, and we'll try to not ask.
It's
We will
safe
lose
to
our
say,
jobs.
No, it's safe to say that there are a lot of features that we're seeing in the air, and we've been in a real panic in order to understand the orbits of the rings in order to target them. One of the things I became involved with are the looking for and identifying and characterizing what the ring system of Neptune was. And that's a process of rather tediously looking at the frames as you get closer and closer. And it turned out to pay off.
Voyager's first images showed incomplete rings, or ring arcs. Now long exposure images reveal something more.
ring. Oh. And it goes all the way around.
Carolyn Porco, leader of the ring investigation, announces the finding.
Values for you yet, but we, as some of us suspected, we are now seeing continuous rings in the Neptune ring system.
That's a fantastic discovery. You know, this is the way these things pop out. Somebody comes running up to you and says, "Wow, look what we got!" You go in there. Great, fantastic. You're getting incredible pictures. You probably all seen the ring movie images that came down this morning, and many of you I know have noticed that more than one ring could be seen even in the raw images, the so-called ring arcs.
The media expect these new images and discoveries to be explained and interpreted virtually on the spot.
Was that smooth today with with captions and...
Things went very smoothly today. My only complaint is the stuff that came from atmospheres where it was just cut and dry.
The most interesting science was coming in, and my team of scientists were wrapped up in that. I had to hold them back and direct their attention to the responsibilities of getting captions written, getting the science summarized.
Today. So you'll have the best color from either the stuff that came in this morning or the stuff that hits the ground at 3 o'clock.
Candy Hansen is our interface between the imaging teams and the Voyager project. We have a number of instruments, all wanting to look at different things, and there's only so much time and so much computer capability aboard the spacecraft, and so it's a competition. Candy has just gone in there and fought for us.
Looked at, and if it does even contain a piece of the south feature, I'd like to have at least a speaker slide made of that.
Voyager would send back to Earth more than 9,000 images. Each arrives as 640,000 dots, which are computed, processed, stretched, and enhanced to yield photographs. As Voyager closes in on Neptune, its cameras reveal a planet very much alive. Giant cloud features change in a matter of hours. One persistent feature is a small white cloud nicknamed the Scooter, which races around Neptune's southern pole. On the night of closest approach, Neptune's satellite, Triton, comes into view, bringing new images and new puzzles.
The best part is that all of this is going to be in the shed.
What is it?
It's a crocodile of the solar system.
The thing about these encounters is that there is a very intense experience of discovery, much more intense than normal scientific activity, where if you make 1 or 2 discoveries a year, you really feel you have a very successful program. On these encounters, you make many discoveries every day.
Now Voyager must fly over Neptune to reach Triton.
The only way to fly close to both Neptune and Triton was to go over the north pole of Neptune, some 3,000 miles above the cloud tops, and then down to a close encounter 25,000 miles from the surface of Triton. In order to do that, though, we had to go very close to Neptune, and we had to penetrate the ring plane just outside where the ring arcs are. The danger is, what are you going to find accumulated in the ring plane? The ring plane is where all the material tends to accumulate.
It's going to be an anxious moment because we're moving along at tens of kilometers per second relative to Neptune or anything that's in orbit around it. And all it takes is something the size of a BB or smaller to hit the spacecraft in a vulnerable place, and it's all over.
We go to the opening.
Yep.
We come to you.
Right.
You give us the distance and time. Okay. And we come back to you. You say a few words. We say, let's have examples of star occultations. Right? You want the tape then?
Yes.
Okay. Then we come back to you.
Rich Terrell trades his imaging team duties for a new role as NASA's broadcaster to the world of the dramatic ring plane crossing.
Okay, now still store, I've got this picture of the ring arc, and you've got that other picture of Triton.
Terrell begins broadcasting 2 hours before the ring crossing, which is scheduled to occur at 10 minutes past midnight.
I'm your host, Rich Terrell. At 10 p.m. Pacific Daylight Time, the spacecraft is 95,000 kilometers or 58,000 miles and speeding away from the planet at a speed of 55,000 miles per hour.
As Voyager follows its course toward the ring plane, members of the imaging team keep vigil in Building 264.
And we're starting a little bit early today because we have a special event about to occur. With us is Ed Stone, Voyager project scientist, and Don Gurnett, principal investigator of the plasma wave investigation. Comment on the ring plane crossing.
The data that we're receiving right now is being plotted here.
Voyager's progress is tracked by an instrument on the spacecraft called the Plasma Wave Science Experiment.
The very most recent data is right there.
Mission scientists can watch as the graph registers tiny particles bombarding the spacecraft.
It's just dust, that is micron-sized, micrometer-sized particles. It will cause a lot of signal for Don's instrument, but it won't hurt the spacecraft at all. If there are BBs, on the other hand, that could be a very serious problem.
Well, it should have happened by now.
It's 59 right now. I don't know how good the prediction was. Ring plane crossing.
So, Candy, when do we know that?
Is that what you guys asked me? Yeah, about 10 more minutes.
Why 10 more?
No, it was at 11:59.
In fact, you can see that peak right there. That is probably exactly the ring plane crossing where it goes up and reaches a peak.
What? You better do a 90 return.
It looks like it went down. And we're still receiving data, right? A sigh of relief.
Voyager's survival of the ring crossing is more than a celebration of another mission accomplishment. It is also the beginning of a farewell for a team that has shared a 12-year, 5 billion-mile journey.
I'm sitting here.
Now what we're waiting for is the approach to Triton. And that'll begin in 2.5 hours. And those will be the highest resolution images of Triton we've seen so far. Very much better than what caused a considerable amount of excitement here 2 or 3 hours ago.
New images of Triton show surface features of the Earth-sized moon that appear to have been formed by winds.
I think that's a wind streak.
Oh, they're wind streaks, no question about
How
it.
can you have a wind streak with such a tenuous atmosphere?
Yeah, you get the winds to
Follow
blow.
migrations, you had to blow very hard.
You get the winds to blow fast enough.
Yeah, but you calculate how fast it's got to blow in a several millibar atmosphere.
Obviously, it knows how fast to blow because it's certainly streaking that material out.
This is something else.
Just get right ballistic
As
wind.
views of Triton arrive, Voyager scientists are eager to know more about its atmosphere. For planetary geologist Larry Soderblom and satellite expert Torrance Johnson, evidence of an atmospheric haze may hint of a volatile world.
Then as we flew closer and closer, it was the atmosphere was clear and we could see complex geologic detail. And so everyone was happy except for the atmospheric scientists that were hoping to see hazes. And then just as the cameras scanned over during one of the near encounter sequences to the horizon of Triton, there it was, a haze.
They're just perfect.
Do you see a limb haze? Come on, let's stretch it. Do you see a limb haze? Let's switch it. You guys see a limb haze? When we looked at the limb, that is the edge of the Triton, against black space, we saw that there were clouds standing above the surface. We call that a limb haze. It doesn't completely surround the planet like a uniform cloud, but it's localized in certain regions.
Well, now that we got that,
Here we go. Here's the stretch.
I guess the last thing we have to figure out are these dark things, right?
Last
The icy surface of this frigid world has few impact craters and shows evidence of extensive geological activity during its history. Huge volcanic calderas appear to have been flooded long ago by a lava of water. Triton, with its icy polar cap of frozen nitrogen and methane, is the coldest world yet visited in the solar system.
Extraordinaire. Et bon, il y a d'une part le moment historique qu'on est en train de vivre, tout le monde en est tout à fait conscient, et d'autre part, il y a des scientifiques qui s'accumulent et qui viennent les unes après les autres.
Carolyn, BBC, they want to know about rings. Triton hasn't stolen the whole show, baby.
International interest extends to the imaging team's Soviet member, Sasha Basilevsky, who ponders the chemical makeup of Triton's icy terrain.
Nitrogen. Some people say that might be mixture of liquid of water with methanol. Methanol means something close to alcohol, something like of vodka.
Carolyn, we're going to go just with Triton this morning. No ring or atmosphere or stuff.
That's fine.
When the Triton images came in that night, it was clear that Triton was going to be the subject of the press conference as far as imaging was concerned. So we set to work about 3 o'clock in the morning, poring over the data, trying to put together some picture of what it all meant.
Triton leaves scientists with a wealth of information and new mysteries to explain. 10 a.m., Friday, August 25th. The International Press Corps gathers one last time to hear of Voyager's final encounter.
Well, as Ed has said, we have now seen Voyager's last planetary object, Triton, as the spacecraft begins its journey into interstellar space and that interstellar mission. And all we can say now is, wow, what a way to leave the solar system.
Voyager is sailing into interstellar space at nearly 1 million miles a day, free now to float forever through our galaxy of stars. The weekend after closest encounter with Neptune, the Voyager imaging team meets for a final farewell.
And I think we should have a show of hands. Who's here from that 1972 imaging team?
Come on, Brad, higher!
Come on, son of a...
Way up here.
1972! Yay! And I'd like to salute the people who've been running the imaging team from then on, and I'd say it's the best way to run any NASA experiment, and I wish there'll be another one run like this.
The next toast has got to be to Deputy Imaging Team Leader, who gets totally out of control up at the press meetings from time to time, but Larry's been with me from the beginning.
He has a
Great.
champagne bottle for every planet.
All right, well, here's, I've got a...
This group of men and women helped create a special moment in history. Voyager gave us our closest look at faraway worlds.
For giving Brad a vacation. And keeping him out of our hair so we can set this up right so that so he can get the big bang out of it. Here's the Brad.
With Voyager, not only you feel close kinship with the spacecraft, but there are over 1,000 people that really made this encounter happen. You spend a lot of time with those people. In fact, a lot of times you spend more time with those people than you do with your own families. And over the last 10 years, you've gotten to know those personalities as well as the personalities of the spacecraft.
We got all the unimportant toasts over with first. Okay, here's to Kennedy. We couldn't have done it without her.
The imaging team has shared life's milestones for a decade. Some have named their children after the planets and their moons. Others remember years past by Voyager's encounters. For some, Voyager is an inspiration for the future.
It'll be Christy's choice as to what she wants to do when she grows up, but she's at least going to grow up knowing about the planets and what they look like and what their names are, and that it's okay to be a woman and have a fun, exciting, scientific job. Yeah. Even though you miss mommy at times. Yeah.
The real story is that if I really think about what's happened in the last few days, it's intellectually perhaps one of the most stimulating times of my life. Emotionally, it's one of the saddest. I mean, here for the last 10 years I've worked on this mission and always anticipated one encounter after the next, realizing they'd be fantastic, realizing that there'd be things totally unexpected. And it's over. We've done it. We've finished the first reconnaissance of the entire solar system. We've rewritten the textbooks. What do you do next?
Paris, France is Brad Smith's last stop in the journey to the edge of the solar system.
With the Voyager observations of Neptune now, there will be a need to produce maps. And the maps have to have names. So craters have to be named, features on Triton. The satellites themselves have to be named. And so there's a need right now to provide that nomenclature to the scientific community.
The Paris headquarters of the French Space Agency is host to this year's meeting of the Nomenclature Committee of the International Astronomical Union. These astronomers give names to the newfound features of our solar system.
Tuonela, Tuonela, which is a Finnish sacred lake, which should be in there, sacred sea.
This name is very popular in Russian culture. From Greek.
Members represent the Soviet Union, Norway, France, and the United States.
In choosing names in the Neptune system, we try to maintain a self-consistent theme. For example, Neptune is the god of the sea, and the previously known satellites, Nereid and Triton, follow in that oceanic mythology.
Well, we're really doing two things, I guess. One is to assign names to the features that we've all agreed need names, but then the other thing we need to do...
We do not ever name features after religious leaders. Political leaders have to be dead about 1,000 years.
In terms of the discovery of Neptune. And,
just now, it's the bicentennial of the Declaration of Human Rights. Not the French Revolution, that's something different. French Revolution, even if it is the universe, but human rights, that is completely universal. And the symbol of human rights is three words: the liberty, equality, and the fraternity with brotherhood. See? And so my suggestion is the following, you see? And it's not the French, it's not something French, universal. So my suggestion will be the following. It's not national.
Astronomers do astronomy for different reasons. I personally am just interested in how everything came about, and in particular how we came about. And that means we need to try and understand if we are alone or whether there are other solar systems.
The desire to know whether we are alone in the universe draws Brad Smith and Rich Terrell back to Chile each year in search of other solar systems. A stop at the seaside town of Coquimbo breaks the long journey to the observatory. Smith and Terrell never make the trip without paying their respects to an old friend, Mario.
Antes nunca estuve así enamorado, no sentí jamás esta sensación. La gente en las calles parece más
Mario, ¿cómo va?
Gracias al amor. Antes nunca estuve.
It was on an earlier trip to Chile in 1984 that Smith and Terrell took an intriguing picture of a star. The image suggested that planets may have formed around it. The star was Beta Pictoris.
Beta Pic is a fairly nearby star. It's only 50 light years away. That seems like an enormous distance. It takes light 50 years to travel there at 186,000 miles per second. But it turns out to be one of the nearest 1,000 or so stars in the solar neighborhood. That's a small number compared to the 100 or 200 billion stars in our galaxy. To give you an idea of how far that is, if you imagine our sun the size of a grain of salt, then the nearest stars to the sun would be about 7 miles away. Beta Pic, on the other hand, would be something like 80 or so miles away.
We have now looked at something of the order of 130, 150 stars, both in the northern hemisphere and down here in the southern hemisphere. But so far, we haven't found anything else like Beta Pictoris.
The challenge of detecting planets directly is that the material you're looking for is about 1 billion times fainter than the star and much, much closer. So it's buried in this enormous glare from the center star.
The problem of seeing planets in the glare of a distant star is a great challenge. But finding another planetary system would be an historic event in astronomy.
Yeah, that was a nice sunset. The seeing now is just as good as the night is clear. We'll be in good shape.
Looks like another good night.
It's a good night.
Okay, it looks pretty good. Looks like we might want to move.
The detection method Smith and Terrell use involves blocking the glare of the star's light to look for planets around it.
And what we've essentially done with this mask is it's like when you look up at the sun and you put your thumb in front of the sun so you can look very close. We've done that in the telescope, creating, in a sense, a miniature eclipse. We've eclipsed the center light from this very, very bright star.
Smith and Terrell's original picture of Beta Pictoris seemed at first unexceptional. But computer processing revealed a slight extension in the image. Color coding showed the extension even more clearly. Smith and Terrell interpret this image as a disk of material around the star seen nearly edge-on. Other observations suggest that there is an empty region in the center of the disk, a hole that may have been cleared by the formation of planets there.
I think we ought to reobserve some of these. We saw these last year, but that was under pretty poor seeing conditions, and we can go much deeper if we use a bigger mask.
Yeah.
And we should take advantage of the seeing.
Well, we should do Beta Leonis again, and HR 5670, HR 5825, that was a really good candidate. HR 1998 would be good.
The search will continue until the day that astronomers find a star with planets. Until then, we can dream of other worlds, alien landscapes that may even harbor life.
Walking by someone's an astronomy office down in La Serena, and I saw a sign with a quote on it. I don't know who said this, but it said, "Hydrogen, a light, colorless, odorless gas, which given enough time, turns into people." And that's really what science has found. We, humankind, are a piece of the universe which has become self-aware. I think that science's goal now is to understand the universe. What we try to do is put that great puzzle together. The exciting thing that we found is that the processes that led to the evolution of life are fairly common.
We know what the chemicals are, that the elements that are responsible for life, and they're ubiquitous. They are everywhere. They are the most common elements and molecules in the universe. If you can get these materials together in the right environment, and by the right environment, I mean a solid body, a planet, at just the right distance from its star. This is a natural process. This is chemical evolution. It's going to take place anyway. There's no way to stop it.
you look at the numbers, the vast numbers of stars and potential sites out there for the evolution of life, you can't possibly deny that it can't be occurring in many, many places. And quite literally, there are more stars in the visible universe than there are grains of sand on all the beaches on this planet. Next time you're at the beach, run the sand through your fingers and try to imagine only one of those grains of sand containing a blue planet like the Earth. I mean, I think you'd have to be crazy to really believe we're the only civilization out here.
This is PBS.